Yesterday, I attended a training about profiling and debugging, and the speaker, William Wolf, apparently said, if we're not aiming performance, why bother using C++ anyway? Maybe we like pain. But let's talk about performance. My name is Simon Davydov. I work at Sukhoi. Sukhoi is known for its fighter jets. Fighter jets is an extremely complicated vehicle in terms of control, and every bit of a mistake you might make may cost you everything. So pilots need to be trained hard prior to the first flight. I'm a team lead of a group where are developing training systems for pilots, and one of them is a fighter jet dome simulator. This one is not ours, it's Su-27, but it's a nice photo I managed to find on the internet. And our rig looks pretty much the same, but for some reason I'm not allowed to take photos of it. So, we use Qt, not only Qt, for the whole stack, starting from hardware abstraction layer to the indication itself. And our indication is solely based on Qt. Every pixel you see here is Qt for real. Wait a second, I'll start the simulation. It's not a real simulation, just a model. So every pixel you see is Qt. And this is about 7% roughly of the interface of the real UI possible. The main action has happened on the navigation page, but I'm not allowed to show you it. So, the question is, how do we control all of these pixels, and what about performance? Let's address the first question first, about control. Here. Won't it be nice to have an object on the QML side from which you can read all of the data you need and even get notified that the data is changed? And if you'd like to even have an ability to write data inside this magic object, and you like to update it by yourself, let's see from the player's perspective. Basically, all you'll need to show indication is a player. We have here one. Here it is, here's a player, and indication itself. And from the player's perspective, won't it be nice to have an object where you can write from any data you get from the logic layer and get notified every time this object is updated from somewhere else, in order you have an ability to pass your data back to the logic layer. And won't it be nice, again, if QML code would know nothing about C++ code, and C++ would know nothing about QML code. See, it all comes down to a magic object. What can it be like? Let's think of a table of triplets of name, type, and value. And after being loaded, the table becomes an object, and all of these triplets become properties of that object. So we can name this object from now on PropertyMap. And the abstract JSON representation of that map may look like follows. There are over 6,000 properties in this table. And all of them are powering this UI. Now there are roughly 50 properties changes simultaneously, but it can actually handle all 6,000 of them. But what is PropertyMap exactly? PropertyMap is a QObject, is something that looks like QObject with notifying properties. It's crucial that properties must be notifying, because QGadgets can have properties as well, but not notifying ones. So we're interested in notifying only. And there are several implementations possible. The first and the most obvious one is to use QObject itself, because no one would argue with the point that QObject looks like QObject. At this QObject, all the data should be encoded into QObject and the subclass of QObject body by hand. All these getters, setters, property declaration, data fields, and so on must be explicitly added to the object. I'll show you. And if you'd like to implement all the 6,000 table, you better dust off your favorite scripting language. You can use Python, for example. I'm not insisting though. Now it's time for a little demo. I'll start it out. Here they are. We have 3,000 properties. This number in the middle of the screen is not a frames per second, actually. It's updates per second. It's how many time updates can be done in 1 second. But since the whole complexity of the scene is not high, this update takes the whole time in the scene. So it's mainly CPU bound, not GPU bound. Every item you see is controlled by 3 properties: X, Y, and rotation angle. And this is a static property map. All the properties must be added prior to the compilation step. And this will take eternity to compile, because don't forget this. Don't forget QObject macro, because mock will be happy to see all your 6,000 properties. The mock CP file would be huge, and the binary size would be huge as well. And it will take eternity to compile, as I just said. In the world where static property map exists, let's call this approach static property map, because we will need it later. And the land where static property map exists should be exist dynamic property map as well, and it is. It's called QQmlPropertyMap. Let's compare them. We can see the pros of the QObject. It definitely runs, but that's it. It's bulky, all the properties must be known at compile time, constantly needs to be recompiled, huge binary size must be synced with QML, and no way to detect either QML or C++ updates property. We can simulate this behavior, these 2 static property maps, but that requires changes in QML code. So it failed to keep QML code and C++ code separated. On the other hand, we have dynamic property map, which has map-like API. Properties can be added at runtime at any point of execution. Doesn't affect compilation size nor binary size. And what is crucial, it's emit value change signal every time property is updated from the QML side, because when I have a cockpit, I should know if it's me who controlling the handle, or if it's logic layer who controlling the handle. Let's look at this one. This is throttle control handle. This one can be controlled by airplane itself. It's like cruise control in your automobile. So when I move it by myself, the QML actually emits value change signal, and so I know that it's me who controlling the handle, and I can override that behavior in airplane model. So looks like all pros about QQmlPropertyMap, but what about cons? I'll show you. Comment it out, comment in, stop. Oh, I forget to do the also. See? I think it's all obvious. We have a little issue here called performance. So, the cons of the QMlPropertyMap, it's bloody slow. Performance is more like health. It's unnoticeable until it starts to bother you. But before addressing the performance problem, let's address the less tricky problem first. With the static property map approach, all the properties are instantly created by mock, created at compile time. But with dynamic property map, all the properties must be explicitly inserted at some point. I'll show you insertion code for both of them. So that should look like this. Is it visible? Make it larger for you. The only interface of incident properties QMlPropertyMap has is insert. The properties are inserted one by one. And let's insert a bunch of them. I have a special test for that. Looks like follows. I have an exponential scale of numbers, 1, 2, 5, 10, etc. I'm creating property map and trying to insert that amount of properties, the number of properties inside it, and measure the time it will take. And after putting all these points on a plot, I can see a nice looking curve commonly known as the parabola. And that effectively tells us that the algorithm inside is proven to be n-square. But incidentally, it wasn't cube before. Back in days, it's cube 5.2. There was an issue about QQmlPropertyMap bad performance at insertion. And many thanks to Simon Hausman have fixed that. And now it's n-square. Looks like people with name Simon are in charge of fixing QQml property maps. I tried out the I tried to point out the current problem, but no luck. As you can see, this is marked as duplicate. I left a comment there stating that this is not a duplicate, but another problem, because that one was n cubed, and now it's n square, and it feels like it should be linear, but no luck. But since it's n square already, now it's my turn to make it linear. Okay. We keep talking about properties, but what is property exactly? Property itself, just name and the type, and that's it. A property physically is a part of table called QMetaObject. It consists of mandatory name, type, optional, notifier, and several other attributes. We have API for property. It's called QMetaProperty. You can obtain it from QMetaObject by index. And the property is just a record inside a table called QMetaObject. It doesn't store any user data in it. QMetaObject is just a table of meta information about methods, signals, properties, and that's it. It's up to you how you will store your information. You can store it directly inside the class, like with a static property map approach, or you can use any third-party data structure like vector, for example. And you can see the API of QMetaProperty, this one, I mean this one. It requires your object as a parameter because QObject is a device for which you have the access to your data. So your property doesn't store any data. And QMetaObject itself, the table I was talking about, it's immutable. It actually doesn't have any methods to insert something into it or to remove something from it. Let's find here the C QMetaObject doesn't have any methods which alter it. So how are we supposing to add new properties there into QMeta object if it's immutable? Qt uses the builder pattern instead. We have QMeta object as a private API. No documentation so far. You can use QMeta object to shape your upcoming new QMeta object. You can add your properties inside QMeta object. And then you're ready. When you're done, you just ask QMeta builder to build actual QMeta object for you. That means if you need to insert a new property inside QMeta object, you have to rebuild it from scratch. What does it mean in terms of performance? It means in n square, because the complexity of building is linear. So if you'd like to add a new property and you have to build it from scratch, you keep building all the properties you already built again and adding a new property, and so on, so on, so on, so on. That means n square. So if you'd like to fix QQmlPropertyMap's slow insertion, we have to extend the API, because there is no any way to say, hey, hold on, don't build QMeta object right away. I have some new properties to come. I have to extend the API. And that's quite easy there. We can just do what insert of QQmlPropertyMap does, but in a loop. That's code. I just copied the code of actual QPropertyMap. So it's pretty much the same in order to extend its API. That's the conventional insert method that can insert property one by one. And after every insert operation, the new QMeta object is recreated. So if we'd like to have an ability to add many properties at once, we should extend its API. I have a bunch of these. I'm not sure which is more appropriate, so I implement all of them. And insert itself calls internal Q property. It's not that. No, okay, it's more like the same. Yeah, here it is. QQml open meta object. So if we call this set value several times in the loop, like we have here, let's see first what set value is responsible for. It tests if it has property already, because insert property if it doesn't exist, and updates the current property if it exists. So it tests property if you have one, and so it creates new property if it doesn't exist, and updates the property if it exists, and then calls activating it. So all you have to do is to do the same, but several times. So we can call insert many times in a loop. Here in a loop, I just copied code from insert, and that will do the trick. At this point, the insertion became linear, so I consider the n-square problem fixed. I'd like to propose it in order to be included into QQmlPropertyMap itself. That's good, but it doesn't solve the performance problem. Just for so, it's 6 times more slow than static property map approach. And there is more. Every property you'd like to insert inside QQmlPropertyMap is tested against a set of names, which are reserved ones. I wonder how are you to call your property QObject or delete later. It doesn't matter. We can save some CPU cycles if we omit this test or make it optional. So if we have insert like this, we can just disable. If we're confident about our names, why bother testing them any time we insert them? It's like the problem, not the problem, like a trade-off with vector add versus vector subscript operator. If you're confident about the range, why testing it? And since we know how to fix this, let's proceed. I haven't much time left. Let's proceed to the third approach. I call it quick property map. Since we know all the pitfalls, we can implement a new property map by itself. That's the tricky question, why static property map is faster. Because if we look deep inside, we will find that QQmlPropertyMap uses index to access its properties, and static property map, as mock generated, use switch selector among the huge table of indexes. That's pretty much the same in terms of performance. So why static property map is faster? And it turned out that the whole meta object system API stays the same all the time. And the only thing that varies is QMeta object, because static property map has a static object, only one static QMeta object, which is generated by mock. And with QQmlPropertyMap, we have a dynamic object, dynamic meta object, which stores all the properties it has. So that's the only difference. And QML somehow fills the meta object you uses, or kind of meta object you use. And with dynamic meta object, wait a second, I'll show you something. If I open any meta object, no, it's not. Here it is. This method is generated for us by mock. It's a selector. It actually tells external code which meta object I'd like to use, static one or dynamic one. And static property map doesn't have any dynamic object, so this is always null with static property map, and static meta object is returned. And with dynamic property map, this is true, and dynamic property map is returned. And that's the point. This is how QML knows what kind of meta object we use. So we can play a trick on this. If we somehow tell QML that this one is null, but at the same time return dynamic meta object, we can select this. That will do the trick and mislead QML. QML will think that we use static meta object, and deep inside JavaScript engine that involves there is a selector which has two options: to cache properties and not to cache properties. And with dynamic meta object, it uses slow linear search. And with static meta object, it uses fast cache lookups. But happily, meta object is a virtual function, so we can override it. And that's what I've done this with QQmlPropertyMap. That's the API. First, I made an explicit API for adding properties. You're adding properties until you're happy with the number of them, and when you're happy, you explicitly call build. And this builds QMeta object. After that, add property has no effect. detect are appended to the intermediate property list until you're okay with it, and then you build it. Second, we have insert, index-based insert. Because QMeta object is an index table, we can make an API that uses index for that. Because if you know the correct index, for example, if you have QAbstract item model on top of your property map, why bother using names? Because it's slower, you can use index right away. And the name-based insert just uses cache of names. Here it is. Property index is a cache. Uses cache inside in order to speed up the whole process. I'll show you the demo. Yeah. This one is 3 times faster than static property map approach. So accelerate faster on all of them. There are little tricks inside, so we have literally no time. I can't show them to you, but I have the code for you. So you can try it yourself. All the code I show you, you can find on GitHub. That's all I've got today.